let's remind ourselves how we go about multiplying and dividing fractions. So if we start with some numeric examples, like a half multiplied by 4/5. When you multiply fractions, there are two processes or two ways that you can go about doing it. My preferred method is to first simplify between the numerators and the denominators, and you can always do that in a bow tie shape. So if there's your multiplication sign and you just extend it to a bow tie, it means that you can simplify that numerator with that denominator, or you can simplify that numerator with that denominator, or you can simplify that numerator with that denominator, or you can simplify that numerator with that denominator. So long as it is a top with a bottom, you can simplify across the multiplication sign and within the fraction between the numerator and the denominator. So here, if we look at a half times 4/5, that's 1/2 multiplied by, I'm going to just do this step by step. 4 can be rewritten as 2 times 2 if we do it as powers of prime numbers. We can then divide that 2 by that 2, and we're left with 1 times 2. Now we just multiply what's left in the numerator by what's left in the denominator. So that's 1 times 5, which is 2/5. The other way that you could go about doing this would be to first multiply. So first multiply the 1 by the 4 and the 2 by the 5, and then simplify the fraction that remains. So 4 is 2 times 2, 10 is 2 times 5, 2 divided by 2 is 1, and we're left with 2/5 as our final answer. When we divide fractions, for example, if we have 2/3 divided by 7/8, we need to first change the divide into a times and multiply by the reciprocal fraction. Now, all that reciprocal means is if you had A over B, your reciprocal would be B over A. It's just turning the fraction the other way around, making the numerator the denominator and the denominator the numerator. So that becomes 8/7. If we look here, 2 and 7 don't share any common prime factors, neither do 8 and 3. So we just multiply the numerators and the denominators, and 16/21 is our final answer. Let's have a look at how that applies in algebra. So in algebra, because it is a simplifying process, we start off by factorizing, and then we simply simplify by dividing the like factors in any numerator by any denominator. So long as it's a numerator with a denominator, we can't go wrong. And then we multiply what's left in the numerator, and then we multiply what's left in the denominator. So, for example, we first start off by factorizing. A minus 4 is already prime, so we can just put it in a bracket to remind ourselves that we need to consider that as a single term if we simplify. A squared minus 2a minus 8 is a trinomial, so we can factorize it into a minus 4 and a plus 2. We need to change the divide into a multiply and multiply by the reciprocal. So the a minus 5 and the 1 are going to swap places. So a minus 5 will go into the numerator and 1 will go into the denominator. We can now divide or simplify by dividing any like factors. So a minus 4 can divide with a minus 4. Remember that anything goes into itself once. So in the numerator, we are left with a minus 5 because 1 times anything is itself. And in the denominator, we are left with a plus 2. Here are some examples for you to try on your own, so please pause the video. Number 1, start off by factorizing. 3x squared minus 25x minus 18 will factorize into 3x plus 2 and x minus 9. 27x plus 18 has got a common factor of 9, and that will leave you with 3x plus 2. Change the divide to a multiply and swap this fraction that comes after the divide sign. So this 5x squared minus 33x plus 18 is going to go into my numerator, and I'm going to factorize it. Its factors are 5x minus 3 and x minus 6. The 5x minus 3 is prime, it doesn't factorize, so we just put it in a bracket. We now divide the numerators by like factors in the numerator with like factors in the denominator. So 3x plus 2 divided by 3x plus 2, 5x minus 3 divided by 5x minus 3. And now we just multiply what's left. In the numerator we have x minus 9 and x minus 6. And in the denominator we are just left with 9. It's not necessary to multiply out in the numerator. You may leave your answer in factorized form. Number 2. B squared minus 2b minus 15 factors into b minus 5 times b plus 3. 8b plus 20 has got a common factor of 4. That leaves you with 2b plus 5. Change the divide to a multiply. The 4b plus 10 now becomes the numerator. That has a common factor of 2, which gives you 2b plus 5 in the brackets over 2. You can now divide like factors, so 2b plus 5 divided by 2b plus 5. Remember the bow tie shape. Any numerator can simplify with any denominator. And the 2 divided by the 2 is 1. That leaves us with b minus 5, b plus 3 in the numerator, and 4 in the denominator.
In the fraction to be simplified in worked example 2, the highest common factor is not as obvious. Remember, when we multiply or divide top and bottom of a fraction by the same thing, we must deal with the whole of the top and the whole of the bottom. We cannot just scratch out the a's and b's. The first step is to factorize whatever we can. In this case, we take out the common factor on the top and on the bottom. X is the common factor of the numerator, and y is the common factor of the denominator. Now we can see that a plus b is a common factor of the top and the bottom. So we divide top and bottom by a plus b in step 2, leaving the answer x over y. In worked example 3, we have to multiply two fractions. This means that we multiply the two numerators and multiply the two denominators as in step 1. In step 2, we factorize each part of the numerator and each part of the denominator. In the numerator, we factorize pm minus pn by taking out a common factor. We factorize the trinomial in the usual way. In the denominator, we factorize m squared minus n squared as a difference of two squares. Once we have factorized, we divide top and bottom by any common factors in step 3, and find that the complicated-looking expression can be simplified to get a simple answer, p. Can you see how important it is to be able to factorize expressions? It is much easier to work with p instead of the original expression. When we are dividing fractions, we try to make things easy.